Raindrops of radius 1 mm and mass 4 mg are falling with the speed of 30 meter per second on the head of a bald person. The drops splash on the head and come to rest. Assuming equivalently that the drops cover a distance equal to their radii on the head, estimate the force exerted by each drop on the head. So we have been given that the raindrops are there. Okay, let's say this is a raindrop and the raindrop's radius is 1 mm and mass is 4 mg and the speed that with which it is falling is 30 meter per second. So these are the given quantities. Now what I will do is I will take the downward direction as the positive direction and upward direction as a negative direction. That means what? All the quantities which have directions, okay, just like displacement, velocity, acceleration, okay, those quantities like these which are having downward direction will be taken as positive, and if they have the upward direction then they will be taken as negative. Okay, now this radius r is 1 mm and this drop falls on the head of this bald person with a speed of 30 meter per second. Now I can always assume that the liquid drops center of mass is here at the center. Assuming that the drops are spherical, I can always assume that the center of mass is at the center of the sphere. So as if the whole mass of this liquid drop is concentrated at the center of this sphere. Now this distance covered will be r. So the distance covered by this drop is r, okay, before it comes to rest. So now I will apply this equation. V square is equal to u square plus 2as. So what is this V? V is 0 meter per second because the final velocity is 0. The drop is splashing, right? And this will be u, which is 30 meter per second. So this will be 30 square plus 2 into acceleration into r. So r is 1 mm. So this is equal to 0, 30 square plus 2a into r. R is 1 mm. So 1 mm is nothing but 10 to the power minus 3 meter. So we will take this towards left. So this will become minus 2 into 10 to the power minus 3 meter. So this will have the dimensions of velocity, meter square per second square. I am not writing these dimensions, okay, the units, okay, you can write them. So this is 30 square and into a. So what is the value of a? Value of a will be 30 into 30 divided by, this is minus sign by the way, into 2 into 10 to the power minus 3 meter per second square. So this is 15 and 15 3s are 45. So this is minus 45 into 10 into 10 to the power 3 meter per second square. So what is the acceleration? Minus 45 into 10 to the power 4 meter per second square. This is the acceleration. Now they are asking us the force. Now the mass times the acceleration will give us the force. So the mass is 4 into 10 to the power minus 3 kg. 1 milligram is 10 to the power minus 3 gram. Okay, so this is 10 to the power minus 3 milligram, right? Now they are asking, we have to write the answer in terms of Newton. So I will convert again this gram in kilogram. So this is 4 into 10 to the power minus 6 kilogram. So this is the mass. So the force which will be applied is MA is equal to 4 into 10 to the power minus 6 into minus 45 into 10 to the power 4. So this is the force applied on the drop, right? Because this is the mass of the drop and the acceleration. So same equal and opposite force will be applied on the head of the person. So 45 into 4 is 180. So I will write this as minus 180 into 10 to the power minus 2. So this becomes minus 1.8 Newton. So the force applied on this drop is minus 1.8 Newton. That means the force has upward direction, because upward direction is negative. So the force applied on this drop is upwards. Okay, so this is 1.8 Newton. But we have to find out the force exerted by the drop on the head. So now, since always valid, I can say that same amount of force will be applied by this liquid drop on the head of the person. So this is 1.8 Newton is the answer.